So today we have a very short lesson, but it is super interesting. According to me anyway. Unit 4, Lesson 11. Most equations you've solved have had one solution. Some equations have had two solutions, such as x squared equals 81. Equations can also have no solution or an infinite number of solutions. So we are going to look at a little bit of everything today, just so if you come across them, you don't think you've done something wrong because there are more possibilities. So if we look at the first one and we notice that it has parentheses, we're going to say that side needs to be simplified. So we would do 3 multiplied by both parts inside the parentheses and get 3x plus 6. Now you'll probably notice that the left side, 3x plus 6, equals exactly the right side, 3x plus 6. If we take 3x away from both sides, you get 6 equals 6, which is a true statement. It is every single time, no matter what, the value of 6 is equal to the value of 6. When that happens, you can say that this original equation had to have infinite solutions because the left side matches exactly the right side. But you have to prove it. You have to get down to a single value with no variable equal to that same value with no variable. Next one. If I start by noticing, nope, I don't have to do any simplifying. I'm just going to take away 4x from both sides. Negative 2 equals 2x minus 2. All right, two-step equation, add 2 to both sides. I get over here 0 equals 2x. A lot of people get to this point and either think they've done something wrong because they try to cancel this out. It's the only thing on the left side of the equal sign, negative 2 plus 2, which means we have to put a number there. And negative 2 plus 2 is 0. If we try now to divide both sides by 2, if I have nothing and I divide it by 2, I still have nothing. So x can equal 0. Nothing wrong with that, nothing illegal. It has exactly one solution, and that solution is x equals 0. This one, I noticed that the left side needs to be simplified. I would multiply both parts by 5. So negative 5x plus 10 equals negative 45. I would subtract 10 from both sides. It was a plus 10, so I would subtract 10. Negative 5x equals negative 45 minus 10 is negative 55. Get a lot of mistakes on that. People jumping too quickly to take away 10. But since the 45 was negative, taking away 10 makes even more negatives. I would divide both sides by negative 5. And I would get x equals negative divided by a negative is positive 11. So these are two sort of traditional standard. There is one solution, nothing too funky or strange. The next one that we have here, 2 getting distributed, would be 2x plus 3 equals 2x plus 6. And you should already be thinking something is wrong. How can 2x plus 3 be equal to 2x plus 6? So let's see what happens. When we take away 2x from both sides, you have 3 equals 6, which is not a true statement. So if you, opposite of the first one, get to a point where you have two values, no variables left, and they are actually never equal to each other, 3 will never equal 6, this one would have no real solution. So first one had infinite solutions, just realized there was an S missing there, and this one has no real solution. There is no value of x that will make that original equation true. Ooh, we got a couple here with x squared, so let's see what happens. If I subtract 3 on the left and subtract 3 on the right, I get 4x squared equals 100. I have multiplication, so I'm going to divide both sides by the 4. X squared equals 25. The inverse of squaring is square rooting. So you're going to see me square root the left side and square root the right side, and I get x equals plus or minus 5. This is one of those where the answer, the solution has two values, right? Positive 5 or negative 5. Because if I plugged it back in, 5 squared is 25 and negative 5 squared is also 25. So this one has two solutions. And we've seen that one before, just wanted to put it in the mix. Last but not least, if I subtract 3 from both sides here, I get 4x squared equals negative 100. And you're thinking, okay, not a problem. Divide both sides by 4. I can do that. X squared equals negative 25. Okay, I'm okay so far. But if I try now to square root both sides, I cannot square root a negative. So this would be no real solution. So several different scenarios that can pop up that sometimes students think they've done something wrong when they've done nothing wrong, and they just need to know how to interpret what they've gotten to. So if you hit a dead wall here where the two numbers are actually equal, it's infinite solutions. If you hit a wall here where the two numbers cannot equal each other, it's no real solution. And the other one that we know happens is square rooting a negative is not possible for real numbers, so no real solution. And the one that we've seen before, two solutions when you try to square root as your final step in an equation.